Welcome back, everyone, to Beyond Bandwidth, Leviton's podcast series where we dive into network technology's hottest topics. I'm your host from Leviton Network Solutions, Roy Chamberlain. The discussion for this series is based on DAS. Today, Leviton's Senior Product Manager, Mike Connaughton, is talking with Michael Cassel, the Director for Wireless for the infrastructure consulting firm Aecom. Let's see what they have to say.
All right. Thanks, everybody, for joining us for another episode of Beyond Bandwidth. You know, as we're talking about this season about DAS, trying to include people from a variety of perspectives, and today we're going to be talking to someone from the consultant perspective. So, Michael, why don't you introduce yourself and tell us a bit about what you do?
Okay, thank you. I'm Michael Cassel. I am the Director of RF Engineering and the co-leader for the wireless team at Aecom under the Technology Solutions Group. So we are consultants covering a wide range of wireless telecommunications, including commercial and public safety DAS, public safety radio systems, Wi-Fi, wireless data connections, and all sorts.
All right, great. Thanks for joining us. Great background there. We didn't talk about this before, but I think kind of a topic that comes up when we talk about DAS, especially 5G, with all the kind of promotional activity that's gone around 5G. There's a lot of people that start questioning, is 5G or DAS gonna replace Wi-Fi? Is that a question you hear? What's your perspective on that?
Yeah, I hear that question and comments about that all the time. You know, like most things, right? It's the answer is always, it depends. It is a technology that should replace Wi-Fi in places where that super low latency and mobility are valuable. So say in robotics on a supply chain floor. So say Amazon has robots running around. If you've ever seen one of their warehouses, they're running around constantly. And that mobility on Wi-Fi gets difficult as they hand off from one access point to another. It's not always as seamless as 5G. And in fact, that latency as well is very important in those applications. There are applications like surgery, remote surgery, that latency is important as well. So that's a good application for it. And some other things that you can imagine where those factors are indeed important.
Yeah, that's one of those things where I'm talking to people, I kind of talk about Wi-Fi as being untethered. Just because you're not plugged in doesn't mean you're actually
Correct.
moving around, as opposed to mobile.
Yeah. Portable versus mobile end users.
Right.
Portable being,
right.
I can pick up and move it. Mobile being, I'm constantly in motion.
Yeah. I'm talking while I'm on my way to the conference room, as opposed to I'm talking in my office and then I'm talking when I'm in the conference room. So, going back a bit into your history, as we look at these wireless, and more specifically, I guess we are focused on DAS here. How have you seen the architectures change? What did it look like, let's say 5, 10, 15 years ago, as opposed to what people are putting in today and what you anticipate going into place in the coming years?
My gosh, I'm old, so I remember what it was like 40 years ago when cell phones were, telephone calls were made over two-way radio systems. In the last 20 years, it's really, there's been a lot of change, particularly on the commercial side. Back in the day, so to speak, everything off air was what you call bandpass. So a BDA would amplify an entire band, and it might carry multiple operators. So AT&T and Verizon might both be utilizing that band, and you'd have to set up those systems and balance those two operators so that they worked equally well. And then it was all coax from there on out. And fiber systems were very infrequent. And also dedicated signal sources, a base station, was extremely infrequent. Today, it's completely the opposite. Most systems are fiber if they're of any size. Most systems of any size have a dedicated signal source. And then you also have a separate class. You have the consumer class of products that fits into the smaller venue applications. And those are all off the air almost exclusively. They kind of have a wide range of effectiveness and features that distinguish them from each other.
Yeah, and you're talking about I think generically the terms I hear are kind of fiber DAS or active DAS, kind of used interchangeably, and then passive DAS, which is that consumer grade.
So you have a couple different variances from there, right? You have fiber DASs that are fiber to the edge, which we usually call them fiber to the edge, hybrid DAS, and passive DAS. So a hybrid DAS would have fiber to remote units that then feed coax to parts of the building. So you might have, we'll have a number of remotes that each have their own smaller DAS that all contribute to the larger system. Fiber to the edge generally doesn't have any coax to it, or might have jumpers to a small co-located antenna with the endpoint, but it's almost all fiber.
Yeah, so those would be, correct me if I'm wrong, the biggest systems. That's what you're going to see in the NFL stadiums and such.
So fiber systems, it's not simply the largest venues. It really depends on specific applications, the specific venue, and some other factors that are in play. For example, if a venue has a ponds installation where there's fiber everywhere and we can just run on that, a lot of times fiber to the edge makes a lot of sense because there's no infrastructure to install. We've had cases where in some of the old government buildings, getting through walls is difficult. Those pathways are very, very hard, and fiber's a lot easier to pull through than a half-inch piece of rigid coax. So we'll use those there. And that might be even a different hybrid system in the sense that particular building, we did a hybrid system in the hallways. So you had remotes that fed antennas, multiple antennas in the hallways. And then in the suites on the other side of the wall, those were all fiber to the edge. So it's really a matter of picking the right solution for the application.
Yeah, so now I would say most users, when they're interacting with it, are going to be more kind of traditional commercial environments as opposed to those, larger cases where there's huge buildings and huge volumes of people. Another thing you tend to hear in I'll say the advertising aspects of it, maybe not advertising, but the promotional aspects, is as you go into 5G, connectivity becomes more important. I do believe, part of it is the technology moving to longer wavelengths, and then the business imperative for connection. Those combination of things drive the at least potential need for more DAS connections in I'll say, typical office environment, carpeted office environment. Is that something you're seeing? Is there really a difference as we go from 4G to 5G, that there is an increasing demand for DAS capabilities or DAS installations?
I believe so. It's almost like the curve, because there's an install base of DAS, right? So the number of available venues is decreasing, but the demand as a percentage of those venues is probably increasing, which has made it relatively stable in terms of the number of opportunities you see. And we also have a lot of upgrades. There are a lot of systems that have been installed for 7 or more years that have been in service. And that's typically 7 years is what we think of as the lifespan of a typical DAS. So there's a lot of venues that have those older systems that are coming around, starting to have a lot of problems and really need to get replaced.
And from going back to that passive versus an active DAS environment, where is that cutoff in your mind? I know it's not exactly black and white, but from your perspective, what is it that drives it? You gave a couple of examples of kind of unusual building environments, but assuming kind of standard buildings that are, let's say, less than 20 years old, when do you start looking at an active DAS versus a passive DAS, or going from the other end, how long, what conditions can somebody maintain the use of a passive DAS without having to worry about moving up to the larger systems?
Right. So you can run passive DAS off of the consumer grade products up to probably aggressively 50,000 square feet. It's probably more like 30,000 for a typical office building maximum. And it depends on products, right? Each one has different powers and some of the other factors that are involved in terms of, your off-air signal levels and things like that. You really don't see a lot of industrial grade passive networks at all anymore. I haven't seen one in years, where you have a BDA and you'd feed a passive network. You may have a signal source, in a lot of the phone stores, a T-Mobile, AT&T, Verizon phone store, they'll have a dedicated signal source that feeds a couple antennas in the store to ensure that they have good service, oftentimes. My opinion, you really look at an active hybrid or fiber to the edge DAS when you get to about 250,000 square feet. Some of the consumer grade products will claim to do more than that, and they can in certain circumstances, but they're typically not the ideal solution for that type of size of space when you're talking about a commercial office building type of venue.
Yeah, one of the things that we look at, or we talk about, we Leviton, is, taking advantage of structured cabling. You mentioned that use case if somebody has a PON in place where, there's an existing infrastructure of fiber cable and, you can leap onto that. When we look at smart buildings more generally, we look at kind of horizontal cabling using twisted pair and backbone cabling using fiber, and kind of regardless of your building infrastructure, that's typically what's being put into office space.
Right.
I'm talking about, again, that's what's being put in place. Now, do you see advantages in that? Do you think because traditionally the passive DASs have used coax cables, and not just traditionally,
Right.
still today, there's a fair amount of coax. Is there an advantage to you, going into a customer and say, all right, you can utilize this category cable that's going in anyways, or is that not really an issue to you?
Absolutely. I mean, if it's category cable in there, we will look at one of the consumer grade products actually utilizes that instead of fiber for their connection from their head end to their remote units, or their coverage units, as they call them. And that's actually an excellent product because it's the only product in that category that actually will decode each of the carriers, which is really a channel. So think of it as a channel. It'll decode each channel from each operator, and that will automatically level set those channels so that when they're rebroadcast within the DAS, they have equivalent coverage. Whereas some of the other, all of the other consumer products, you have to balance that signal going in, try to balance that signal going into the unit for it to have equal coverage. And what usually happens is you'll have pristine coverage for one operator, and the other operators will have some degraded coverage relative to that pristine coverage.
Again, just thinking of the terms passive versus active, that's almost like a combination between the two. Technically, I know what you're talking about. That's categorized as a passive or a consumer grade DAS, but it is doing some of the work that an active DAS does in that balancing of the various inputs.
Absolutely true.
Now, another use case I'm curious about, we're going to be trialing it here, I think. I'm going to take a walk as soon as we hang up here over to the expansion we have going on a couple 100 yards away from me. We are putting in a DAS, and one of the things that we're going to be trialing is using the private network capabilities for some of our machinery and the equipment and some of the process control is what I was trying to come up with.
IoT,
the process control. Yeah. Is that something you're seeing more of? Is there a use case there more today than there was, a couple of years ago? Or is that, again, something that we're just hearing about is kind of coming along with the rest of the 5G noise in the world?
There's certainly significantly more demand today than there was a couple years ago when there was virtually none. But it still has a long ways to go. So it's really useful in some very specific applications, say like a hospital or large IoT centric applications, like a 5G private network in that Amazon warehouse that I was talking about earlier is a fantastic solution to manage all that. They have security, It's a little higher security in some ways than Wi-Fi. The aforementioned mobility and the number of devices that can connect to it is enormous. So those are some really good applications. We haven't yet reached the vision of it being a real DAS replacement. So private networking does have a development cycle that includes allowing calls to be routed out to the end user's provider. So if you have a Verizon phone and you walk into a private network equipped building, what would happen is they would recognize that you have a Verizon SIM. They would route that traffic so that you could authenticate across to Verizon, and then that traffic would be carried across the private network and routed out to the Verizon RAN, which would then route your traffic as normally. That has obviously great value because you can get both the private network and public DAS, so to speak, the equivalent of public DAS, all in one. So far, all of those agreements and all of the all the hurdles haven't been covered. So we're still not quite there. When that happens, if that happens, then I think you'll see a much bigger uptick. So in the meantime, really those places where you want to have either a quick deployment where you might be doing a construction site that would allow you to put in a private network and do everything you need to do from radio over IP to voice over IP to data, everything. That's a great application for it. And then some of the specific applications, like I mentioned before, healthcare or manufacturing are good use cases.
All right. Excellent. Just before we finish up, anything else that comes to mind when, this conversation that we're having that you think would be of interest to people hearing us chat about?
Yeah, let's go back to that whole discussion of 4G versus 5G. Because I think a lot of people are confused about what 5G is. A lot of people aren't, but a lot of people are. We talk about 5G being deployed at higher bandwidths or at higher bands, higher frequencies. That's not necessarily 5G element. That's more of a circumstance than a property, so to speak. The real value of 5G from that standpoint is because of the way FCC has deployed spectrum, there's more spectrum available at those higher frequencies. And the more spectrum you have, the more throughput you have. So whereas LTE is limited to certain bandwidths, 5G and R can go up to 10 times that bandwidth, which really equates to about 10 times the throughput. Because oddly, the spectral efficiency for practicality purposes is about the same between the two. So it's really just a matter of the occupied bandwidth of the signal.
It was kind of a similar thing when 3G moved into 4G, and now we're going through 4G, and then there was LTE, and now we're moving into 5G. It's really a grayscale as you're moving through that transition.
Yeah, this is the first time we've moved from 1G to the next and not really seen a significant increase in spectral efficiency. But there's a lot of value to 5G that we've talked about. And I don't know that it's necessarily we're ready for it quite yet in terms of our general demand of the general user. But we will be, certainly in the very near future. So one other thing that's interesting on that a lot of people don't understand is currently, especially in the US, 5G is deployed as an add-on to 4G. So your phone actually does all of the communication and setup, verification, the SIM verification across 4G and communicates there first. And only then will it hand up to 5G if it's available on the network. In the near future, probably in the next 2 to 3 years, I'm going to guess. You never know with these sorts of things, but they'll move toward standalone 5G. And really the limiting factor is the handsets. You can remember when we got rid of 2G, right? And if you had a 2G only handset, you had to get a 3G handset, and the same 3G to 4G. Eventually that will happen here too. If you have a handset that's not 5G compatible, it'll be useless. But for now, they're doing it in this hybrid mode for that reason, so that 4G phones can still work on 4G and 5G phones will go to 4G and then hand up to 5G after authentication.
Yeah, the first place I actually myself experienced or remember experiencing it anyways was my car updating. I had to go through an update in my car because I think it was set up for, might have been 2G. Can't remember if it was 2G or 4G, but 3G. I think it was 2G because they were sunsetting it, and had to do a software update in my car to shift it over. Now, it was a software update, not a equipment update, but it was because the 2G carriers were being shut off and the GPS and everything else in the car was using that to communicate. All right. I appreciate your time. Appreciate your expertise.
Thanks so much. It's been fun.
Beyond Bandwidth is a podcast series produced by Leviton Network Solutions. For more information on the topics we talked about today, as well as other enterprise or data center network infrastructure content, or to check out all available episodes of Beyond Bandwidth, visit us on the web at leviton.com/beyondbandwidth, or wherever you normally listen to podcasts. If you enjoyed this episode, we'd appreciate you leaving an honest review in your podcast application. Along with word of mouth, leaving a review will help others find our show. I'm Roy Chamberlain, and this was Beyond Bandwidth. Until next time.